Hi, friends. It's Mrs. Golding, and I am here back with you on your math packet, page 9, and this is number 6. And boy, am I going to be glad when page 9 is done. Here, this problem says, compared to a human brain with a processing speed of 2.2 billion megaflops, the fastest supercomputer is about blank times as fast. Okay, so processing speed is how fast we can, calculate things or the speed at which we can do things. Okay, so they're trying to explain that a supercomputer is faster than our brain, but our brain is much more important than a computer, right? For sure. Okay, so here's the data that we found from the last problem, problem 5, and we're going to use it in this problem. It says the IBM built Pangea 3. That's what the one we already talked about in the last problem. Its processing speed is 31.7 petaflops of processing power. Okay, so we have to somehow compare 2.2, this is what we're comparing, 2.2 billion megaflops to 31.7 petaflops. Okay, billion means we're multiplying something times 10 to the 9th power, right? Because it has 9 zeros. 1 billion has 9 zeros. But the mega part of the flop is multiplying times 6 again. Times 10 to the 6th. Okay, so I know this is all very confusing, but it's like putting 2.2 with 15. 9 plus 6 is 15 zeros. Okay, and petaflops, right? That word peta means, that prefix peta means we put 15 zeros. It's times 10 to the 15th. Okay, so if you notice, this is going to end up being the same amount of zeros. So to make it a little easier for you to see this, I am going to advance to this next slide. See if it'll let me do that. Okay, this slide here shows the prefixes that we just talked about: peta times 10 to the 15th and mega times 10 to the 6th. Okay, and then we're going to go to this next slide where I put this all in the place value to help you see why we do what we do. Okay, we said there for the brain, and so what I did was by adding all these zeros, I changed it all to just flops instead of megaflops or petaflops. So the brain flops are 22 with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Here's the 15th, right? That's 2.2. So that's the 15th. So there's 14 zeros and then there's that. This one, 31.7, here, the 0.7 is the 15th one, right? So everything is going to cancel out. Well, we don't, it's not really canceling. These are all like ones for dividing, right? And so we want to figure out how many times bigger this is than this. So let's take this and divide by that. Well, rather than use all the zeros, let's just take 317. Come on, calculator. 317. And we're going to divide that by 22. Okay, and we get 14.4. So if you look at the original problem at the beginning, 14 times as big is closer to 10 than anything else. And it's probably because whatever values I chose were a little bit larger. So our answer that we're going with for this one is 10 times as fast. Great, thanks.